Hello, this is Math 145 talking about Module 7. This video is about transformations of, you could say, a function, giving you a new function, but mostly it's a geometric idea that we're looking at a graph and we're moving that graph around. So the first and easiest example is vertical shifts. You start with any function like y is f of x and subtract something from y minus b. What does that do? You could say it shifts the y-axis down b units. But you can also say it shifts the graph up b units. Shift the graph of f of x up b units. Let me look at an example. I said y is 2x minus 3. Look at the graph of that one. When x is 0, that's a negative 3. When x is 1, it's a negative 1. When x is 2, it's positive 1. And the whole graph is a straight line. It's not a complicated example. Now, what happens if we want to shift this, say, 2 units up? So I'm saying we need to look at y minus 2 is 2x minus 3. And okay, if you want to have your function equation in standard form, just add 2 to both sides. So you get y is 2x minus 3 plus 2, and the whole graph gets shifted up by 2 units. So it's here and here and here. Parallel lines. Red line is shifted up by 2 units. This is all pretty standard, pretty easy. To begin with, my example, 2x minus 3 would be the graph of y is 2x shifted 3 units down, right? Everybody can imagine the graph of y is 2x and you shift that 3 units down. So it can shift up or down. And that was the easiest transformation. Next up is horizontal shifts. So again, start with y is f of x. And now it's the same idea. If you shift the x-axis left by let's say a units, it shifts the graph to the right by a units. By a units. This has always bugged me when I was, I think, in high school when I saw that for the first time. When I'm subtracting something from x, why does it shift the graph to the right when I'm moving x to the left? But you can really think of it as in a picture, if you keep the graph in the same place and you literally move your x-axis to the left, that amounts to the same thing as if you kept the x-axis in the same place and you move your graph to the right. Or if that a is a negative number, then the whole thing is to the left. Example. Y is x squared minus 1. Let's shift that to the right by 2 units. So what do we need to do? We grab every x and replace it by x minus 2. Notice how I put a parentheses around that x minus 2, so the squaring hits the entire quantity x minus 2, and not just like x minus 2 square. That would obviously be something quite different and also wrong. If you graph it, when x is 0, the first function, that gives me -1. X is 1 and -1 gives 0, and it goes up. So it's the parabola. And then my transformed function, when x is 2, it gets me to -1. When x is 3, it's a 0. When x is 1, it's also 0. When x is 4, it's +3, so up there somewhere. And 0 also 3. Here's your shifted graph. And even with my scribbles, it's pretty clear. Yes, it shifted 2 units to the right. You try it out for yourself. If you want to shift it 2 units to the left, you need to go with x plus 2 quantity squared minus 1. Okay, horizontal shifts, vertical shifts. You could also combine these and shift your graph in the entire plane to wherever you want to. So it's quite powerful. Just imagine you got the power, okay? Maybe one more example. Whereas a few more x's flying around. F of x equal to 3x squared minus 1 divided by x minus 5. Shift that 2 units to the right. It means, again, replace every x here by x minus 2. So it gets me to y equal to 3 times x minus 2 quantity squared minus 1 divided by x minus 2 minus 5. And just go with the formula and replace your x in there. You can worry about the domain later. The original function obviously had every number except 5. The new function will have every number except 7. That's also shifted 2 units to the right. Well, little surprise. Or no surprise at all, I should say. Okay, last kind of transformation is flips. First, let's do a flip about the x-axis. How do you do that? You're having a function, y is f of x. I like this sort of setup with a y equal to, because it's really, it tells you what happens to the graph of the function when we do all these transformations. What do we need to do? The y values need to flip. That is, they get replaced by the opposite. So just write negative y is f of x. That'll flip your graph about the x-axis. Fine. Flip about the y-axis. 3 guesses. Maybe you can figure it out for yourself. So I would pause the video at this point. And since you paused it, I can go straight on. If you have your y as f of x, your flipped function should be y as f of negative x. And that new function will have a graph which is the mirror image of the original one, with the mirror axis being the y-axis. So let's do examples. How about y is, let's shift the parabola that I had earlier. X minus 2 quantity squared minus 1. Flip it about the y-axis. Minus y equals 2. X minus 2 square minus 1. Okay, you can multiply the entire equation by negative 1. That's probably nicer, because we like our functions with the y all by itself. So we get y is negative the whole splodge. That, it'll have the flipped graph. And you can flip it over. Should I sketch that? Okay, I probably should. The original function looked like this. The new function will be hitting the x-axis in the same place when we flip that about the x-axis. And in the middle, when x is 1, what's happening? My sketch is wrong. Look at the original function one more time. When x is 0, the whole thing is 3. When x is 1, the whole thing is 0. That's more like it. When x is 3, the whole thing is 0. like that. And when x is 2, it's -1. So, original function. Flipped function, it's the x-axis in the same spots. And when x is 2, this time it's +1. So it's going to go like that. Check it out that it really matches those 3 points. And when you've got 3 or 5 points, you can start to really guess what the graph looks like. Okay. Horizontal flip, same function. Come on. I mean, a flip about the y-axis. This time I need to go replace every x by -x. So I get this. And because, well, this particular function, because we're squaring this, we can rewrite the whole thing as x plus 2 squared minus 1, which turns out to be the graph of the original function shifted 2 units to the left. So it's an example that I've mentioned earlier. What does it look like? Original function was this. Flipped function goes through that point, through that point, that point. Looks like this. It is beautiful. Not that hard, also powerful. So really it belongs in Math 140. I love that stuff. But there's even more beautiful stuff. And okay, I should mention one more thing. Sorry, combining the transformations. I've already done here shifting sideways combined with the flips, right? What happens if you combine the flip about the x-axis and the y-axis? Combine flip about x and y-axis. What happens then? Well, as an equation, it's actually easy. You just need to start with your y as f of x. Then you flip it about the x-axis first. Okay, fine. Y is f of -x. And then you flip it about the y-axis. You get -y is f of -x. You're working with that second function, and you just put an extra negative sign in front of the y, which we can rewrite as y is -f of -x. So writing down this equation, that's it, okay? Combines the flips about the x and the y-axis, but geometrically, and that is a surprise probably for many of you, what happens is a rotation. This will rotate the graph of the original f of x that you started with, that one, by 180 degrees about the origin. See if you work with our old trusty example. y is x minus 2 quantity squared minus 1. Do those two flips and you get y is negative x minus 2 quantity squared minus 1. Of course, you can rewrite this if you want as x plus 2 quantity squared. And I see that I forgot one crucial parenthesis, namely, better use brackets here. It used to be just the y had a negative sign, and like I did here when I explained it, I rewrote the equation so y is all by itself. I multiplied both sides by -1, which gives me that y instead of -y, but I need to multiply the entire right-hand side by -1. And with the bracket, that's what's happening. The -1 here needs to hit also the -1 at the very end. Okay, so what's the graph of the original? Done it a couple times now. Graph of the original, x minus 2 quantity squared minus 1. And the shifted function, what does that do? If x is 0, for example, I get -3, which is down here somewhere. Notice that the 3 was up here, -3 is down there. When x is -1, I get 0. When x is -2, I get +1. X is -3, I get 0. And -4, I get -3 again. And for every one of those points, you can check that it gets rotated about the origin by 180 degrees, which is a particularly nice rotation because it just means make a line to the origin and go the same distance but the other way, and you hit that corresponding point on the red graph. So this is how you can easily do a 180 degree rotation with a couple example points and then sketch that graph.